All right, so we'll start the recording here and we'll get started.
Also, Marcus, what's with the Blue Jays on the...
Because Game 7 versus Seattle is tonight, and if they win, they go to the World Series for the first time since 1993. So, the game is at 8:08. Class will be ending sometime before 8:08. I will be listening to 590 The Fan on the drive home.
How long's the drive?
45 minutes. So I will see most of the innings. I'll just miss like 2. Anyway, so that's great. The Blue Jays are doing well. Unfortunately, we're here to talk about game engines, not the Blue Jays. Today we're going to look at how we can actually use our models. So it's great. I've seen you all develop all kinds of models, texture them, UV them. It's been a fantastic process over the last 5 weeks, and I'm genuinely impressed with a lot of the work that's getting done. Josiah as well, after the last texturing assignment, or the last weekly that you did with him making the book. That was great to see. Now we need to actually take these cool things that we've made and put them inside of something. We want to actually be able to render them and use them, right? Otherwise, what good are they? So I left these in the notes. I won't be using 2022 because I forgot my project files, but that's okay. Okay. This is Unity. I feel like I don't really need to explain too much about Unity as a whole, but the goal for today is I'm going to get you guys understanding how you can take your props and put them in scenes like this. This is the default setup. There's nothing crazy going on there, and there's just a prop I made for a class demo for modeling 2. That's it. Right? Nothing too crazy going on. All that background stuff is built up from the example scene, so we will see that in a little bit. And let's check the download. Still downloading. But we'll get a closer look at that a little bit later. Okay. How many of you are familiar with Unity? I should see everybody's hand. At least I hope I should see everybody's hand. Okay, fantastic. That's great. I didn't do any of the basics here. I'm not going to teach you how to navigate the viewport. I just want to teach you all the things that are important to you as an artist working in Unity. So first and foremost, I'm going to be using that sample scene. It is a great resource. Like, it has resources on VFX, shader effects, using models and textures, kits. If you examine these scenes, you will learn a lot, so I will highly recommend checking this out. It also has 4 very distinct and unique art styles. So no matter what kind of game you're making for DDW, there's probably an example scene here that matches your game style. The hub scene is in a close to photorealism style, as close as URP can get. There is a stylized, semi-realism Japanese environment. There is a hyper-realistic Sahara desert environment using, oh, did this just die? Yes, it did. Okay, I will be yelling louder sorry for the people in the front, but the people in the back still need to hear. And the last environment is an extremely stylized, heavy use of shaders, set up, cinematic fly-through scenes. So any style of game that you've got, there is going to be some kind of scene here that matches, that you can examine, okay? All of these scenes have one thing in common in all of the things that we put together, and that's the 3 things that we need to actually represent our models inside the game. Okay, whether it's inside an engine or any other real-time program, we're going to need 3 things: the geometry itself, the textures, and the material. All right, so by now we should be pretty familiar with all of these, and this is the time where we get to see it all come together. So the geometry is going to come from Blender, as a surprise to absolutely nobody. I've been talking to you about FBX models and settings for a long time now, and this is the one where we actually get to really put it to use. The textures. We learned Substance Painter over the last 2 or 3 weeks, all about getting those textures ready. And then the material, which is something that we create within Unity. So each one of these packages that we're using does something different. And we need a combination of all 3 of them to put our props in the game. Okay. So the first thing we're going to look at is the geometry. I'm going to go through this fairly quickly. It should be pretty familiar to you by now. This is all kind of refresher. But the geometry is going to be our mesh, right? Plain and simple, you've already had to model the mesh out, and now you have it here in Blender. But to get it into your engine, you need to export it. So we've talked about this quite a few times already. Before we talked about OBJs as an option for limited use data sets. They have less information in them, which is better for certain uses. In this case, because we're putting them in engines, FBX files are the way to go, generally speaking. They're binary, they're compressed, and they are less heavy on memory. I'd highly recommend you bind the export of an FBX file to some kind of key, any key of your choosing. I chose Control-Shift-Alt-F because nothing else in Blender by default uses that combination of keys, and F stands for FBX, so that's easy. And I can also use Control-Shift, Alt, and O for OBJ. So I would recommend setting that up. If you don't know how to do that, you go into Blender, you hover over that option, and you just right click and add a shortcut, and you just hit those keys. Super simple to do. Okay. And then export settings. I have talked about these like 2 weeks already. I'm going to talk about them a third because they're important and because you, as the students in this class, have a responsibility. You might have people on your teams that are not in this class, but you still want their work to be consistent. You might have programmers who are just going to help out on art. Maybe they make a box, or maybe they're doing some kind of level building where they're just making boxes to use. They still need to be done in the same way that all your stuff's done. Otherwise, you're going to hit inconsistency problems really, really quickly. So these operator presets are really important to keeping your whole team on the same page and everything in Engine consistent. These settings I've got in the slides. The slides are up. You can download them, take a look. Are my default. But really what matters is that it's consistent within the team. Okay? You can tweak these settings a little bit. You'll see there's options for forwards for changing the default rotation of something. Unity by default doesn't actually match this, so you could change it to match Unity. If that's something you choose to do, just make sure everybody on your team is doing it as well. Okay? From top to bottom, the ones that are important are limiting to selected objects. We're going to want every object in our game engine more or less to be a separate mesh for a plethora of reasons that we'll talk about more over the next few weeks when we get into kitting and building our scenes in Engine. Mostly down to performance. Most of these things boil down to performance, right? For object types, we want to make sure that we're just selecting the type of thing we want to export. In my case, it's just meshes 90% of the time. But if you're doing things like animations, you'll need armatures, right? This is all self-explanatory. Blah, 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 blah. We don't need to touch the rest of it, really. If you want to choose these, you can. Just make sure you share them with everybody on your team. And everybody on your team uses them. I've had these issues all the way up until 4th year. Last year, major issues with the 4th year students because they had 6 different artists using 6 different export settings, 6 different sizes, and 6 different import settings within Unity. So every model they tried to put together broke. Okay, not great. Jason?
So what if you need like one thing changed, like in the middle of the project? What happens then?
Ideally, this stuff is set up from the beginning.
Okay, but so if we set it up where we didn't have like animations checked, but now we're importing something with animations, how does that work?
You're going to want to make multiple presets. So if I open up Blender here, and I hop into export, I think I kind of showed this last week. Once you have your settings selected, so let's say I go selected objects, mesh, geometry to face, triangulate, turn off animation. I can then click this little plus button up here, and it'll let me type in a name. So then I can type, this one with the mesh selected is specifically for static meshes. They're not going to be animated, there's no armature. So I can just say something like SM for static mesh underscore name of my game or game engine that uses these settings. So I'm not going to go through with that, but it would then pop up here. So you can see I've got a bunch of different presets from different times, right? At the very top, select active operator. At the very top one that just says library project, right? That's for a library project that I know I was building in Unreal, so everything is consistent within that library project. Second one, Sedna Unity SM. That was when I was working for a team called Sedna. It's for Unity Engine, and it's for static meshes, SM. So not animated meshes, static meshes. SM M2 UE5 for static meshes for the Modeling 2 class in Unreal Engine 5. And then finally, Unity Jam-Packed SM, right, for my work at Jam-Packed, which is my studio. So once you have these settings saved, you can take these presets, save that information, and pass it off as screenshots or whatever, or even go into the Blender file structure and find those presets and share it with your team. Then I'll make a second one, go armature and mesh, and just click add, and now this one is AM for animated mesh. But everything else is the same.
Then the same Unity project can have files of both sides.
Yeah, as long as everything below include is the same, so transform and geometry, these two need to be the same. The armature related ones and the include don't have to be the same. This is just based on whatever you want to include in the file. The reason it's like that is because the ones in the transform and geometry one are actually going to affect the way the mesh is interpreted, so to speak. So if I have a different scale set up here for different meshes, right? If this one's using all local, but this one's using FBX unit scale, one mesh will come in at 1 Blender unit to 1 engine unit, and one mesh will come in at 1 Blender unit to 100 Unity units. So the mesh will be 100 times bigger, just because of that one change. So all of this stuff needs to be the same, transforms and geometry. It's the other stuff that can be changed. Hopefully that kind of clears that up. We'll talk about that more when we actually start exporting things that use these, especially when we get into animation, like towards the last couple weeks, because that's the next time we really play with any of this. But for now, one takeaway, transform geometry, these should be the same every time. Right? And then within having animated meshes, these should be the same every time. Don't have one animated mesh where this is different than another. They should be the same for all the animated ones. Okay. Then within Unity, these things need somewhere to go. So, welcome to file organization. Yay! How many of you are interested in tech art? Technical art. Okay. This is technically our first technical art lecture. It's a little bit less focused on the artistic stuff. It's going to be a lot of the technical art stuff. As a technical artist, this is part of your responsibility on your team, setting up the file structure for the artists in Unity. Okay? Come up with a system. It doesn't have to be the best system in the world. You're still learning, but come up with a system. Share it with your team. Get everybody on the same page. That's a huge part of your job as a technical artist. You're bridging the gap between the engine and your other artists on the team. Having files set up so they know, okay, my materials need to be made in this folder, my textures in this folder, my models in this folder, is a really easy way to keep everybody organized. This might not be the way that your team likes to roll. Maybe you prefer to have one folder that is environments, and within the environments folder, you have models, textures, materials. And then within the characters folder, you have models, materials, textures, right? However you want to break it down is up to you, but as a technical artist on your team, come up with that standard. Keep everybody on the same page, okay?
I have a question.
Yes?
What would you think of the format where you have a folder for each kind of object? So suppose you had a table, you put a table folder, and then in that folder you put models, textures, and materials, but like for that object, but it's an object space. Is there any like drawbacks you think to that, or?
Yes.
Why?
Right now, as it stands, you guys are making things one material, one object. That is not going to be the case in the future. You will have 16 objects using one material, right? So you could still do it where that's all branched together, but generally speaking, we're going to move away from doing one material per one object and unique textures, and we're going to get into tileable textures, modular pieces, and environment building kits, where you might have 31 different pieces to build just a wall, right? So every one of those 31 pieces can't have its own materials. It's better if they're all separate so that they're usable and quickly accessible by everything, right? If I want to use the same material that a door is using, I shouldn't have to go through the folder structure looking for the door folder to find that material, right? If it's just in materials, I can go, boom, there it is. I can use that on the chair. I can use that on the wall. I can use that on everything else. So that's an okay way when we're doing it right now. In the future, it's just not scalable,
okay.
Right? So we're going to go with a more scalable approach.
Thank you.
Yeah, no worries. So why do I say it's so important to have this file structure and everything set up as a technical artist? It's because you as a technical artist also need to get your team involved in this stuff. And the easier you have it set up for them, the less understanding the more artistic people need to have of the technical side of things, the more likely they're actually going to engage with it. Don't do this. Ever. I will be so sad, but it happens every year. I have to tell people every year, do not use Discord or Google Drive as your file management system. If you're an artist on the team, I don't care who you are or how little experience you have, download the repo. Use Git, right? Learn how to make a commit, how to push. If you don't understand any of that stuff, if you're not sure how Git works, ask your programmers to teach you, right? Have them put you on the organization. If your programmers say no, ask me, I will teach you, okay? But use this stuff. Use the proper tools for the job. I'll use another anecdote from some of my previous students. I had a team that was using Google Drive and Discord for all their file sharing. They had one single artist that actually understood a little bit how to put things in Engine, but even then, not so much. What do you think happened to that one artist who understood? He spent less time doing art and more time downloading everybody else's files to put into the game, right? Huge waste of time. I always come up, I say, hey, the art progress is hitting this wall every week after week. What's going on? Oh, well, every single piece of art that gets made has to come through me to get in. Well, there you go. You're bottlenecking your entire project this way. So don't use these, right? As the technical artist, make it easy. And then as the non-technical artist, use that easier system. Understand, put things in Engine. I want you to contribute and learn to work in the Engine, okay? Like I said, if you don't understand Git or any of that stuff, feel free to ask me or your teammates. I'm sure somebody will help you along the way. All right, that's it for my PSA. Is anybody doing that? No judgment at this stage and where you're at. I just want to know for who might want extra help with getting their systems organized. Bert, is that a...
I think my group was using Discord.
Gotcha. So if you guys want to talk to me about setting up a repository and doing all that kind of stuff, like, feel free. I'm more than happy to help you get all that stuff set up.
We already use GitHub.
Oh, you do use GitHub.
GitHub for the coding and stuff.
Right.
We used Discord to send like 2D images.
Gotcha. Yeah, so still you're going to want your artists to be putting those in directly so that the whole team has access to them at once and everybody's getting pushed up. Okay. So anyway, if you are looking for help with that, I am more than happy to help you. All right, beyond that, the last stage of our geometry is, it shows up here. We export it into the engine, it's in our models folder, and we have a bunch of options that are kind of scary looking to go through. But realistically, these don't matter too much, again, as long as they are consistent. Whatever importing preset you're using here in Unity, make sure everybody on your team is using the same. Ideally, for something like this, it's just the default. That makes it easy. Any questions about exporting our geometry to our engine? Good to go? All right. If you can't tell by my yelling very loudly, this stuff is important because you'll be doing it a lot. Stage 2 is going to be the textures. So we have our geometry, fantastic. Now we have our textures. You'll remember I asked you a question during the last lecture 2 weeks ago. We can't always control the rendering pipeline, so how do we get those consistent results? And the answer was the textures. The textures. So we've made those textures in Substance Painter. You're all now quite familiar, I would say, with Substance Painter. You've made a few things, you've textured a few things. This week you will texture one more thing, sorry, but you got to keep doing it to get better at it. We need to take these textures out of Substance Painter, and we want our object in Unity to look as close to this as possible. There are two ways to do that. But it also kind of boils down to our export settings. And then we'll talk a little bit about the technical aspects behind textures. These are your export settings. If you have a Unity project open, actually I should be downloaded by now. We are good to go. All right, so I'll just create in the background. Hopefully it'll work. Of these export settings, there are only really two you need to worry about, being the output directory and the output template. When it comes to the output template, we have a bunch of presets which make our lives way easier. Okay? All of these by default are included, and you can make your own as well. The power of Substance Painter doesn't come from the fact that it exports these things directly to the engine. It comes from the fact that it allows you to export whatever you want, however you'd like. These presets just get you there faster. Okay? So in this case, if I look at the export setting for URP, so this is the Unity Universal Render Pipeline, which is what you're all using. Over here we have the different types of maps that are going to get exported. And then over here we have what type of map is going into each slot. Okay? The first map is the color map. And I just want to kind of explore how textures work with you. This might be a refresher if you already kind of know. But if we're looking at a texture map like this, we're dealing with a bunch of pixels in an image. Each one has a color value. Easy enough to understand. We can break that pixel down. That pixel has a red channel, a green channel, a blue channel, and an alpha channel. And those 4 channels come together to create our color/pixel. In this case, this brown color from that car jack has an R value of 113, green of 67, blue of 67, and an alpha value of 255. So these values range from 0 to 255, where 0 is black and 255 is white. We can actually examine each channel individually in our textures. So we have the R channel of that color texture, the green channel, and the blue channel. And we put it all together, we get these colors. Right? But within each channel, R, G, or B, those values can only move between 0 and 255. Well, they can only move between black and white. What does that mean for us? Well, if you've exported anything from Substance Painter before, you might have noticed that some of your maps are in black and white. If you're exporting for Unity URP, you'll end up with a black and white map called the roughness metallic map or glossiness metallic map. If you're exporting for HDRP, you'll end up with what's called a mask map, which I'll explain in a second. You're all using URP, so we can sort of gloss over the HDRP stuff, but I want to showcase it anyway. Right? This is what's known as channel packing. So each one of these channels, whether it's your RGB or your A channel, or in the case of the HDRP outputs, you have a different map in RG and B. So that's the only difference between the export settings is what data is going into what channels, what's going in the red channel, what's going in the green channel, what's going in the blue channel, and what's going in the alpha channel for each of our different textures. Right? The reason there are so many different ways to do it is because there are so many variants in shaders. So these are the default shaders in Unity. There is an immense amount of them. Realistically, the only one you're going to be using is the URP lit or URP unlit shaders. But part of the process right now is going to be understanding when to use what shaders and why, and when to make your own shaders. And every time you make a shader, you need to think about what kind of data you need from the textures. So this is kind of high-level stuff. It's a little bit confusing for sure, but hopefully by the end of class you have a good understanding of it. When it comes to HDRP, we're going to look at channel packing here. So this comes from all of those black and white masks that we make. We can actually, since we know the red channel goes from 0 to 255, black and white, we can put an entire black and white map in just the red channel. And we can put an entirely different black and white map in just the green channel. An entirely different black and white map in the alpha and the blue. Every single channel pack map can actually be 4 distinct maps. So if we look at HDRP's default template, right, The reason I'm showing you this is because you might want to use this in your own shaders. You might want to channel pack for your own shaders. The R channel, right, on our color map, if we go back, you'll see they all look pretty similar, right? Because they're all building to the same result. But here, they all look totally different because they're all representing completely different things. So the R channel is just our metallic. It's a grayscale map. The green channel is just our ambient occlusion, another grayscale map. The B channel is actually left open in HDRP for you to tweak the shader and do whatever you want with. And the alpha channel has the glossiness or roughness information in it. Okay? So I'm getting all of this value out of just a single texture. As far as the memory overhead goes, it's one texture. No extra VRAM, no extra file size when it comes to building and shipping my project. But I have the benefit of 4 additional maps. Okay, so this stuff is super powerful for condensing your projects. Now this is HDRP only, I should mention. In the URP, you don't have these options unless you're building your own shaders, but that is something you might look to do later. Okay. In the bottom right of the screen, you do actually have as well a tool in Unity to allow you to check individual channels. So if you're looking at something like a mask map, you can check what the red, green, and alpha and blue channels look like directly in your editor. It's just in the bottom there when you click on your Properties tab. And up at the top, you have your RGB, RGBA settings to fly through the different things. I was going to show you all this in Engine, but again, sorry, I forgot that project. Okay. But we're not done yet, which is tough because I've been already yelling for a while about textures, but we're not done just yet. Any questions before I show you this last thing, I guess? It's probably better. This is like a separate thing. Kind of good to go? Yep.
Just out of curiosity, this big map, you said it doesn't use a lot of VRAMs. So would you say technically if you want to make a game that is really optimized, we should aim to use this type of like tool?
Yep, if you ever do any work in Unity HDRP or Unreal Engine at all, you'll be using channel pack maps. It's only Unity URP that doesn't really make that much use of them. If we go back to the settings, you'll see Unity URP channel packs a couple maps. So at the top there, the base color map in Unity URP also contains the alpha transparency information. So that's technically 2 maps. And the metallic smoothness, same thing. Technically 2 maps, one in the RGB and one in the alpha. So it's a form of channel packing, it's just not nearly as optimized as for HDRP. Right. And it should go without saying, if you have a color map, you need all of those channels. You can't channel pack color maps. Okay, so we've exported our textures from Substance using those presets we just talked about. We set up our maps and got them in our engine. Whenever we add something to our engine, it's going to travel through what's called an importer. It's going to get processed by the engine into data it can use. So this is where that, if you ever scrolled through your Unity project files, you'll see the name of your asset, and then you also see like .meta, right? All that extra information that Unity gives each file. That's a result of it being processed here. So even though it's in, the processor has a default. It's going to take every texture you import and every model you import, and it's just going to be like, okay, this is my default, this is what I'm expecting, you're good to go. But some of these maps, we need to tell it how to compress them, which is basically just some of them have data we can't lose, so they need to be compressed differently. So I have a step-by-step here for actually exporting your textures. And then we'll look at the importer part together. So we're going to start by opening up some kind of textured painter file. Hopefully you have both a Unity project. Yeah, see, so if you try to make that template with Unity 6 or newer, it kind of just breaks. I'm just going to keep hitting continue and hopefully it'll work. So in the slides, you can follow along with this. It should be pretty simple, but it's just a step-by-step for exporting those textures. It's everything I just talked about. The settings are all listed here. You can take a textured painter file. Maybe the book is a good example since that's one you've already done. Or any other weekly assignment that you've textured. You're going to navigate up to File, Export Textures. And from there, we're going to change the directory to our textures folder in our engine that we've hopefully made. And then set our output template to, in your case, a URP. Yep, Lucas? Oh, sorry. Yeah, no, I'm gonna take like 10 minutes here. Sorry, I'm still talking, but this is more like you guys do this on your own here. So download the slides, go through this step by step. I'll check back in like 10 minutes, and hopefully you'll all have textures and engine ready to go that we can start using. Textures and a model. So I'm going to use an FBX. I'm going to make sure I'm using some kind of static mesh for Unity setting. So I'll just use this one because it's the first one here. Export this to the desktop. You might recognize this hammer because it was the assignment hammer. Also, during that quick break, so Noah just mentioned to me, your CG assignment, how many of you are in CG? It's a lot of you, right? So there's an assignment due this Friday in CG from what I've heard. That is quite the tall task. Luckily, my assignment, though it was totally incidental, lines up perfectly. So it's a 3D assignment you're making in CG that involves putting models into a game engine and making them look good, I assume. The weekly assignment for this week is taking models that you make and putting them in a game engine and making them look good. So if you feel like submitting things from your CG assignment, that is totally A-okay with me because I only care that your models look good and they're in the engine. So if you take something and put it in your CG, as long as you submit to me these things, which you already will have once it's in your CG project, that is totally cool for the weekly submission. Sound good? Cool. So hopefully that doesn't add too much overhead. It's just a little bit of extra time to go through and take the screenshots of the stuff you need. So this is live now as well. You can take a look at it. It'll be up on Canvas. So let's get Substance Painter open here. And I don't have any Painter files, so we'll just make a new one. And I'm using that hammer just as an example. We'll give it textures real briefly, nothing crazy, because this part would have been done already. Okay, and then we can do something simple. So this should all be pretty familiar with by now as well. We're making a material, we're adding a mask, and then we're just going to mask out the parts that we want to be this material. And then I'll add a second material for the handle and we'll go from there. Fantastic. In your texturing assignments, you do a lot more than this, but just for the sake of time, we'll call this good. So, I've got my model. I'm going to export my textures. I'm going to want to export them right into my project. So not into Discord, not into Google Drive. My textures are going to go straight into the engine. So find wherever your project's downloaded. In my case, it's in my repos. And this is, apparently it's not in my repos. If you're unsure where your stuff is, you can just right click and show an explorer. Here it is. Oh, it opened in a different Unity project. Oops. So inside of assets, I'm going to start by making those folders, that file structure we talked about. I'm going to hit new, folder, one for models, new, folder, one for textures, a new folder, one for materials. So now we can export these into textures, and the output template we're going to use, because this is a URP project, I'm going to go down to Unity URP metallic standard. So you'll see there's two options there, one for metallic standard and one for specular. That is going to depend on the workflow that you used in Painter. So when you made the Painter file, it asked you, hey, what kind of project are we going to set up? Right? Is it going to be a PBR file? Is it going to be a stylized file, right? Chances are, if you were following along, you use PBR metallic roughness. That was the file template that you were using. And because we're using the roughness and not the specular template, we need to also export it as the metallic. So file, export textures, set everything up. Project assets, textures. And we are going to pick Unity URP metallic. Okay. We have a few options for our export type. Generally speaking, though, the easiest way to do it is PNG. PNGs are lossless, and they contain an alpha channel, which, again, as we just kind of learned, the more channels we have and make use of, the better. Unity also needs the alpha channel because it does have those two channel packed textures where it has color data in the RGB and an extra channel map in the A. So we do need to use something with transparency. So we're going to leave it at PNG. The bit size is going to be the quality of your textures. 8 is fine for all of your cases. Very rarely do we need to bump it to 16, only when we need super high detailed maps. 8 is fine. Everything else we can leave. Right? So once that's all good to go, I can hit export. And you'll see it exports as the name of my mesh, so hammer_low, the name of the material on the mesh, default material.001, and then the name of the map, albedo transparency. Okay, you can tweak that in your export settings if you'd like. If I go down here, you can see what are called regular expressions, and this is how it handles the building of the thing. So right here I've got a $mesh. I'm just going to grab the mesh name and put that into my output. Then it has the texture set. It's going to grab the texture set name, put that in my export, and then the actual name of the map, in this case, albedo transparency. So we export those and we save. And now within Unity, we have our textures appearing right here. So we should all be together at this point. I don't even have the model in here yet, just the textures, but that's okay. Let's talk about those importers that I was mentioning earlier. Okay. Now that we have our textures in, we can look at telling Unity what each of these textures is. So earlier I talked about those importers. They grab it and they just assume that every PNG is the same as every other PNG. But that's not true. For color maps, ones that just use the RGBA channels in standard ways, we can take all those default settings. It is right in that case. The default settings are fine. For black and white maps, like your metallic map, up at the top, the only difference between these two is there's an option for sRGB, or in little brackets there, color texture. If we're exporting a texture from Painter, it will be an sRGB space when it has color. But when it does not have color, it will not be an sRGB space. So we need to uncheck that little box. So your non-color textures, you need that box unchecked, or it will not show up the same in the engine as you see it in Painter. Okay? And then finally, for your normal map, we actually have to compress the normal map differently. If you do not change the setting, your normal map will look wrong, no matter what you do. At the top there, you'll see that there is a option that is texture type by default. We need to change that to normal map. We need to actually tell Unity, okay, this map is a normal map. And it will stop compressing it and allow us to use it properly. Yep.
So I already put in the normal map and stuff, and then it told me.
Yes.
Unity told me that it wasn't.
So it does do that just in case you were unaware when you start putting in the material, and it will ask you to fix it. So it's not the end of the world if you don't, but ideally, you have it done right from the start, it's not a problem. But yes, it will tell you.
Can you explain to me what bitmaps are?
Bitmaps? Have you heard of LODs? LODs and bitmaps, LODs are to meshes what bitmaps are to textures. So as you get further away from a texture, your bitmap level is going to lower the resolution, so it's not rendering as hard. That's essentially it. It's not too crazy.
Thank you.
Yeah, no worries. So let's look at these textures, and I am not going to change those settings. I'm going to leave them. We're going to put them in a material, and we'll see how wrong it looks, so we can fix it. So hopefully my scene has stopped oscillating. Nope. Okay. We'll just stare this way then. That's fine. I need to import my model. So I'm just going to open up that folder and move my model in there.
How come you add properly the materials? You're going to showcase this, right?
Yes, in just a sec. So I'm going to grab that hammer, put it in my project. Then we can take my hammer and just put it in the scene. Okay, so we have our model in the scene. We have our textures exported and ready to go, and we've told Unity what our textures are. I haven't for demonstration purposes. We'll get to. Because this is where the magic happens. Now that we have all of that stuff done, we get to the fun stuff. This is where we actually bring these things to life. So I've done a lot of talking about materials and this and that and textures and shaders. All a material is an instance of a shader. Okay? So the Unity devs have so gracefully coded a bunch of these shaders for us to use. And the way that we make use of these shaders is by creating instances of them and changing the parameters. The parameters that are opened up to us are your textures. So we are putting different textures in to these shader instances, and that's what makes the differences between the materials. So there are a bunch of different types. The default one is the URP lit shader. So there'll be a different one for HDRP. We'll actually ask for different inputs. But for the URP lit material, it looks like this. And we have just a few options. Surface options, surface inputs, detail inputs, and advanced options. Everything from detail inputs down is a little bit more on the advanced side. You don't need to worry about that too much right now. But surface options and surface inputs you will be using for every material you make. If you really like this stuff, because these are instances of code shaders, you can actually just open them up. If you hit the little edit button on your material, it will pop open the actual code that is generated for that shader. Okay? So all the material is an instance of a shader where you can put your textures. The options that are available to us in URP, we have workflow mode, which is going to swap between metallic or glossiness. So if you worked in metallic, we worked in metallic, the default is metallic. You're going to put that to metallic. If for whatever reason you use glossiness throughout this and specular, then you would change this from metallic to gloss specular. I'm going to, after this, go through with you and make a few different types of props that make use of different shaders, so you have a good idea of when and where you need to actually change these things. But for now, I'll just keep explaining. The surface type by default is opaque. Can anyone possibly guess what the opposite of the opaque is? If I click on it, what's the other option?
Transparent.
Transparent. Boom. So opaque is a much more cost-effective way as far as render times goes to render an object. It doesn't account for transparency at all. Whatever object you put this material on, it will be fully not see-through. Okay? If you have an object with opacity, then you need to switch that to transparent, and we can start to adjust opacity that way. Render face. Okay, so by default, every face on your mesh, we've kind of talked about this before with the normals being backwards and stuff. In the game engine, it only renders one side of your face, because rendering both would be a waste. You can only see one of them at a time. You can adjust that. Maybe there's a certain object you want to render the inside and the outside for some particular reason. You can change your shader material to render both sides. Okay. Next two are pretty obvious. For surface inputs, this is where we actually use those maps. And this is why we have to tell Unity what each map does. When we open the shader code, we can see exactly what the shader is doing with each of these textures. And if we're handing it something that it's not expecting, it will break or it will yell at us, like in the case of the normal maps, where it tells us, hey, you need to fix this. So we have options for base, metallic, normal, height, occlusion, and emission. So we've kind of talked about what a lot of these are. You should know by now. So a base map is going to be your color map. Metallic map is which parts of your object are metallic. And the smoothness or the roughness is in that alpha channel for the metallic map. It's packed. We talked about packing it earlier. The normal map is the normal map. Pretty self-explanatory. The number beside the normal map is the intensity. It's a contrast slider. So you can actually make your normals more or less pronounced by adjusting that number. Height map, don't worry about. That's maybe a next year thing, but not something you need to worry about right now. And occlusion map is for ambient occlusion. So if you have ambient occlusion map, you can export it additionally, and that will add self-shadowing. So does everybody understand what ambient occlusion is? Or I can explain it real quick.
I think we could explain it.
I can explain it, no problem. The light bounces around everywhere in a scene, and in our Unity scenes, it's being computed as a bunch of light bounces as well. But the thing is, in tight crevices, the light would bounce an infinite number of times. And that's computationally basically impossible. So what we do is we provide what's called an ambient occlusion map to fake self-shadowing. Where two objects are really close together, you get areas that light just can't reach. It just can't get in there. No matter how many times it bounces, it just can't get in there. We faked that detail with ambient occlusion, but it's a detail that comes from real life. If you look at any two objects in real life that are close together, if you look at the hinge in between your laptop screen and keyboard, you're going to find a little bit of shadowing, right, where the light just can't get. And ambient occlusion maps let us fake that. I can actually show you real quick what an ambient occlusion map looks like in Substance Painter here. I'm not sure if any of you would have used one when you were doing the texturing assignment, but this is what they look like. So you can see all of these little shadow areas where the mesh is intersecting with itself and the light wouldn't get to are going to be in the ambient occlusion map. It's very obvious here, right? The light wouldn't be able to get in there because it's such a tiny crevice. The ambient occlusion is going to handle that shadowing in our game engine because doing it normally would be too computationally expensive. Okay, in this case, I haven't exported it. So if we look here, you'll see there is still some ambient occlusion. What's causing that is Unity does have ambient occlusion built in as a post-processing effect. That's a whole other thing. For now, don't worry about it too much. And then last is emission. Does everybody know what emission is? Yeah.
It giving off light.
Gives off light.
Object goes wild.
Basically, turns anything that you have into a light, right? So you might have something like the light down the middle of the room in your game. And you want light to emanate from that. But if you tried to add a bunch of lights, one for each of the lights in this room, your engine would crash. Lighting is expensive. Calculating that many lights is nuts. But we can fake it using emission. So if you have something that glows like a car's headlights, the tail end of a jet fighter, light bulb in the classroom, you can use emissive to fake that glow. I'm going to explain these in case you feel like using them, but this is not something you really need to worry about. These are the detail inputs. Detail inputs allows you to use a channel-packed mask similar to HDRP and then add additional base information into it and tiling normal detail. So maybe you have something like a massive rock with a big normal map and you want to break that detail up further. You can use a second normal map here to tile detail over the entire mesh and break the big normal up. It's pretty self-explanatory, but actually using it is a whole other thing. I don't have any examples, so it's kind of hard to show you here, but we can look at it in a bit. Advanced options, don't worry about. You basically never need to touch those. Okay. So the step-by-step for this, we're going to right-click and then click Material. That's it. Yeah, you should all know that by now, though, right? We're working in Unity. You've been working in Unity for a couple of years. So let's go in and let's do that. I'm going to open up my Material folder. I'm going to right-click, and I'm going to create a material. So we scroll until we find material. And we click. And the default shader we are going to get is that universal render pipeline lit with metallic as our workflow and surface type opaque. We can call this hammer. From here, we can go back to our textures folder. And we could drag the different maps into the respective channels. So also, I apologize. This is obviously not the default Unity layout. This is my own. I will just switch that back. And I also think I need to adjust this because I just remembered something. That's not on. There we go. Okay. So if we click on the input for each of our maps, it'll pop up. Double click the little circle. It will pop up with all of our possible inputs for that slot. So this is why naming comes in handy. We know that it's named after the model, and we know it's called default material 001. So now we can quickly search. So if I search hammer, we'll find all of our textures. We'll add the base map. Then we'll go to metallic and do the same thing for our metallic map. So hammer underscore low, and down here this says metallic smoothness, so this is the one. Normal map, same thing, hammer, normal map. Okay. So right now, remember, I did not tell Unity what my different maps were on purpose. I'm going to show you what it looks like when it's wrong, so if you ever see it in the future, you know what you need to fix. So I'm just going to take this now and drag it on. It's having a tough time. Here we go. There's my hammer. But it doesn't quite look right. Right? The parts that are at the bottom are lit up bright white, even though the sun is going downwards. So our normals are backwards. Part of that is because we haven't set up our normal map. So let's go back to our textures. And now we're going to change our import settings and tell Unity what each of these is. So change this to normal map. Hit apply. Now my normals look proper. Okay. Let's go to our metallic smoothness. Right now this is set to color texture. we're going to uncheck color texture on metallic smoothness. It is a black and white map. Hit apply. Same with emission, but we're not using it. We can hit apply. Now our object is showing up as it is supposed to in Unity. Okay, much better. The one other thing we can do here is adjust our smoothness. So this smoothness meter is the multiplier on our smoothness channel that's in the alpha of our metallic. By default, it's 0.5, but we want to set that to 1 because we're using all of the value range. So now we have the hammer that looks just like it does in here. Okay? So that's a lot of steps. It's a lot of things we have to make sure of are done for every single asset in the game, which is why it's so important to stay on top of this stuff. There are a few ways we can make this easier though. So this is where the slides end, and this is where we'll do some more demo live stuff. There are a few ways to make this easier. Let's go over to our textures here. If you're the tech artist, I might not want to have to explain to the artists on my team how to interpret all of these and which ones they need to change. So just like in Blender, what we can do is create a preset that the other artists can just click on and use without having to understand any of this, right? So as long as our tech artists understand what's going on with our settings here, we can go up here and clicking this little slider icon will open up the preset window. So now we can create a new preset and save that. So I'm going to go back to Assets, which is our main root folder in Unity. I'm going to make a new folder and call this one Presets. And we want to save these presets in the Assets folder and have them pushed to the engine so that everybody else, or sorry, to the repo, so that everybody else on the team also gets it just by pulling the repo. So presets. By default, it's called texture importer preset. It is a texture importer. I'm going to call it black and white mask input. So we'll just call it B and W map input, or map import. Right. So now, all the other artists need to understand is that when they import a black and white map, which they should understand a lot easier, they just click on black and white map import. So we can save this now. And now when I click this, you'll see it pops up. And if I click, it's going to apply all of those same settings that we did for the one black and white mask. So now every time, all they have to do is import like that. Okay. We can actually take this as far as we want. We can take it as far as writing custom code that will import, and then based on the name of the texture, change its import preset. So we can have it so that if it registers the metallic smoothness maps, it will just automatically apply this importer. Okay, I'm not going to dive too much into that. That's something you can kind of figure out on your own, but it is an option, right? This is easy enough for most people to understand. So I can now pass my maps to my team. My team can import them, and my team can understand that, hey, I need to go up here, I need to click black and white map. Boom. And I can do the same for normal, and I can do the same for any other kind of map to make it easy for my team. All right, and now we have our asset in engine. Perfect. Okay, everything we just did today, that's going to be your activity 6. Like I said, if it overlines with your CG, that's totally fine. But take some asset, ideally make a new one, or make something for CG, texture it, get it in engine. For the rest of the class, what I'm going to do is make a few different types of props, and I'm going to show you the process through Painter and Unity, and when we need to change things like our shaders, right? So we might need transparency in a shader. How can we do that through Painter and Unity? We'll start by making some foliage, which is a huge one for transparency. So let's hop into Blender, and I'll just make a new file. If you're not in computer graphics, then the assignment's still there, but it's the same thing. You'll just be going through these steps that we just kind of did today. Any questions on that type of stuff? Good to go? All right, let's make some foliage. So, foliage is one of those things that makes huge use of our alphas. If we have a leaf, let's say this is our leaf, shoddily drawn. If I wanted this leaf to have topology to match, I would have to add a ludicrous amount of edges to this thing. Right? And we'd have to move them all around and in. Until it matches our leaf's shape. Maybe fine for a leaf that's as simple as this, but they can get a lot more complicated than that if you have like a maple leaf, for example. So what can we do? We're going to use transparency to handle most of the work. And we'll just use a quad or a very low resolution version of our leaf. So I'm going to just go find a maple leaf image. Ideally, you would have something of your own to use. But for the sake of time, I'm just going to use something from here. And I'll crack this open in Photoshop. In Blender, I'm just going to add a single edge loop down the middle and a single edge loop on the sides to kind of create this slightly conical shape. So this is just a few vertices, much less than we had before, which is good for something that we're going to be using a bunch of times. And I can shade that smooth so we don't have these hard lines. So let's open that with Photoshop. And the goal here is we want to add a alpha mask. We want to tell Substance Painter and Unity what parts of our mesh we need to have opacity and what parts of our mesh we don't. So I'm going to go through I'm going to make a new layer out of the background so we can delete the background. Why are you doing this to me? There we go. Okay. So I've deleted the background. And then we can export this back out. We have to export as a PNG because we're using opacity. So I'm just going to send this directly into my engine. under textures.
Did you have it for me to top? Because it was for phone files. So just trying to figure out the important ones. So you know that's when some things might be broken, as you can see they feel broken, but then
And this is the albedo transparency.
from most things.
So we know from our exporting in Substance Painter that these maps need to have RGB for the base color, and then the alpha is where the transparency is going to be. So I'm going to save that. Then we'll take our Blender leaf, quote unquote, and export this to the engine as well. Making sure to use the same preset that we've been using for everything else. Yeah, yeah, just demonstrating the use of the transparency. You would ideally make your own leaf, but for sake of time, I'm just using one I found online. And in models, we'll post our maple leaf. Okay. Granted, this maple leaf is currently 2 meters large, so actually I'm going to shrink it down. Okay. We have our maple leaf texture here in the engine now. And we can look at the individual channels. And under alpha is the key one here. We get to see what parts are going to be opaque and what parts are going to be transparent. So now we've got this black area outside the leaf where our transparency is going to be. So we don't need to create a model that has detail for every single one of these. Another area using something like this is useful in alpha mask. If you're building, let's say, a mesh grate, like the ones at your knees on these desks. You can look at the row behind you if you want to get an idea. If you tried to model out every single one of those holes in that grate, it would A, take forever, B, break, and C, is just not worth it. But we can use an alpha mask, and instead of needing geometry, we can just use pixels to represent those holes in the grate, the same way we're doing it for this leaf here. So there is more use to this than just foliage. And I'll kind of show you both as we go through. So let's make a new material. And we can call it maple leaf. And then under our base map, we'll add that base albedo. Now we don't have a normal or metallic or anything like that, so it's going to give us these sliders we can use. The leaf is metallic at 0. It's not going to be metallic. And the smoothness we can leave at 0.5. Let's drag our leaf model into the scene. And it is extremely small because it's a leaf. But that's fine. It is so small that it's actually getting blocked out by the probe light. There you go. Okay. And now I'm going to show you the other way to add a material to an object, which is to go here instead of dragging it on. And then under the mesh renderer component, we can add the material here. Okay. Would you look at that? We have our maple leaf on the plane. But there's a problem. It's not transparent. And that's because we're using a opaque surface type material here. There are two things we could do. One is to make it a transparent material, or two, use alpha clipping. So if we need something like glass, something like silk, something like the blinds at the back of the class that have some level of opacity between 0 and 1, between just totally black and totally white, we have to use a transparent shader. But if we are building something where we have values of only 0 or 1, we can use what's called alpha clipping instead. So I'm going to leave this as opaque, but I am going to check off this alpha clipping box. Now, alpha clipping doesn't allow us to have those middle values. What it does is it calculates between the black and the white based on this threshold and completely removes whatever it finds. So at a value of 0, it's not cutting out any black. As soon as you go to 0.0 anything, it's starting to cut out the black, and it will continually, it'll continually cut things out as we move the slider up. Typically a default value works pretty well though, right? So now I've got this leaf. I'll just make this massive just for the sake of actually being able to see it. Okay. Now we've got this leaf that is very low resolution, right? The actual mesh is just this, but it has a little bit of a bend to it for some better lighting, and it's alpha clipped to hide all of the parts on the texture that we don't want to see. And I'm trying to remember how to hide.
It's the one all the way on the right.
Oh, thank you. Great. So that's one way we can do things. Let's talk about adding some glass now. We'll make a quick storefront or something of that sort. Maybe it has a window somewhere in it. That we want to be glass. Here's the thing. If we're going to have transparency, generally we can't have both transparency and opaque at the same time. So we need to create multiple material instances when we're trying to do this. We can have opaque materials or we can have transparent materials, but trying to do both opaque and transparent on the same material can cause a lot of problems. So in Blender, I'm actually going to set it up to have multiple materials on this one mesh. I have kind of told you guys to stay away from doing that kind of thing. This is one of those exceptions where it's okay. So the only thing we're going to see here is the inside of the cube, but that's fine. Over here in my materials, we'll add one material. That's our base. And we'll have a second material. That's our window. The names of these materials in Blender does not matter that much because we're going to be using the same material in Unity for all of our glass, basically. I'm going to take our base and I'm just going to select everything that isn't the window. To do this, I'm going to click the window and hit Control-I to invert my selection and hit Assign on the base material, and now it's assigned to everything, though you can't see it, but it is. Then I'm going to click on Window, and click on just the window, and click Assign. And now I have two materials on this one mesh. I'm going to quickly unwrap this, quote unquote. The actual model here doesn't matter. It's just to showcase the materials. Mark some seams so it's unwrapped. And there we go. That should be fine. So let's now export this into our scene as well, and we'll just call this store wall. Same export settings as everything else. You can pop it into our scene. All right. So we don't really have any materials to add to this. I'll see if there's any default ones that we can steal. Or we can apply the hammer for now. I'll create a new material and call this one glass. And for this one, we are going to use transparency. So I'm going to make this transparent. We get a few different options. We have alpha blending, pre-multiply, additive, multiply. To get the right one for your use case, you're just going to have to kind of cycle through these and see which one works for you. But if I apply this now, it'll take a second to compile. And everything looks kind of weird, but we can see it is actually transparent now. Okay, you can't really see it on the projector, but I promise you there is some things showing up through there. And if we change it to any other ones, it's making slight differences that, again, you can't really see on the projector. I don't know if you can kind of see it changing on the projector. Here's the most obvious one, though, right? Now it's completely transparent. All right, you can see it's applying to the entire object like this, so it is better to have it split up into those two materials. So in our mesh render, we can have two material slots that are going to correlate to the two material slots we give it in Blender, where the top is the base and the bottom is the window. So the top one, we'll just use the hammer, just because it's what we have. And for the bottom one, we'll use that glass. And now we're getting transparency where we need it. Okay. And we could have more detail in this glass to give it different appearances. We can make it really shiny, or we can make it really rough. We can add a normal map for chips and cracks and damage and things like that. We can tint the color of the glass. All while it's still one object here. Okay, cool. Between those three, you should have a pretty good base for all the different types. The rest of them aren't used super commonly, but I can show you one more trick with the materials we can do using the face mode. So we're going to make a new sphere. Anything is fine. Shade it smooth. Then I'm going to use Shift D to duplicate this sphere. And I'm going to scale it up ever so slightly. So we have two spheres basically on top of one another. This outside sphere is going to have some kind of material on it, but I'm just going to call it black because it's going to be a void, and we're going to make an outline with it. I'm going to click on the inside shader, or the inside sphere, sorry, and we'll just call this one whatever material. And we can export these together. And call it sphere.
Wait, do we do the inside sphere material?
They both have a different material.
Oh.
So we've imported our sphere. I'll put this in the scene. And by default, all the faces are rendering outside. But we can make the outside faces render inside, the opposite way they're meant to, using our materials. So let's make a new material now. And I'm just going to call this one black outline. I'm not going to need a base map or anything, so I can just set up a solid color. Let's just make it, pure black. And then I'm going to set the smoothness to 0 so it's as dark as possible. And I'm going to change the render face to be the back. So the faces that we're not typically supposed to see. And now when I apply this to this outside sphere, we're actually seeing the inside of the outside sphere. So no matter which direction we look at our object from, sorry for the strobing thing going on back there, I'm just seeing the inside faces of that exterior sphere. You can replicate this effect in Blender. If I use Shift-N and I actually recalculate all my normals inside, so if my normals for this sphere are backwards, it'll do the same thing. So if I export this now with backwards normals and leave this as rendering the front side, we get the same effect. So you can get a cheap outline effect on your object by rendering the mesh twice with some kind of inwards facing normals or an inwards facing material. Either one. Yep, no?
Can you do this sort of back-face tolling without having to actually modify the model, but instead do render it as a separate as a shader?
Yes.
You can also do it as a shader. So this is called just like mesh outlining, but you can make a shader that's called a Sobel outline shader, and that is what you can use to render as a post-processing effect, which is useful for other effects. But yeah, this is like a variety of effects you can do just with materials alone. I haven't even touched on making your own shaders or anything like that. You might do that with Josiah towards the end of the year. But this is just me tweaking materials, and I've already got 4 totally different effects that we can use in our games. So they actually fully explore these effects in this scene. I'm not going to be able to play it because the version of Unity that I built has it broken. And that strobe thing is going on over there. But if you, oh, okay, never mind, forget it. If you go in there in your scene and hopefully everything is working, you can go in and see how they actually did these 3 exact things I just did here in the different example scenes. In the Japan one, you'll see the foliage tricks as well as the Savannah one. The store wall one, you'll see, in the stylized example. And this backwards outlining / Sobel post-processing outlining, you'll see in the stylized shooter one. So all of these 4 effects with materials, you can actually examine even further by just hopping in the different scenes in this project. Again, pretty sure it's broken on my end. Don't expect too much here. Try it for yourself. It's getting there. I don't think it's going to crash. We're slow. Oh, we're getting there. Everything that's blue is just shader compiling. Don't worry about it. There we go. Actually, it did work. Wonderful. Okay. So you can study this scene in your template and get an idea of how they did different things. We're going to learn about, making modular assets like this and putting them all together. So as you can see, this big rock is just mashed together with a bunch of other big rocks to build our scene. We'll learn about exporting individual assets like this as we get into our kit making process. But if we look at the trees here, modeling all of this geometry would be impossible, right? So we are making use of those alpha textures. To handle the detail for us. Okay, we can see the alpha clipping going on here. So if we turn the alpha clip down to 0, there's my actual geometry without the alpha. So there's a lot of stuff you can do with this template. I would recommend playing around with it, taking a look, getting some inspiration from these different scenes. Let's look at the example with the transparent textures as well as the outlining. Okay, so here's a very stylized scene. with all of these spaceships and the like. I don't know if it'll play. No, it won't play. If you play it, it will turn on the outline shader and everything like that. It's post-processing, so it won't actually show up here. It's only showing up when you actually play the game. Would still recommend going through that too, though. Okay. Any questions about anything we've kind of gone over here? Anything at all? Good? Cool. So let's go through and make one more quick prop that kind of utilizes all of the things we just learned. Going to make a potted plant that we can put in and kind of call it there. So I'm going to start with the cylinder. And we'll lower this down to 12 because we don't need that many sides, or maybe 16. And I'm going to shrink it down to cylinder size, or pot size. I'll turn on my keys. Okay. I'm just going to move my 3D cursor to the bottom. And then move my origin to the 3D cursor. And then move my pot to the world origin so that our pot is on the ground. Done that a bunch. Should be pretty self-explanatory. For our pot, I'm going to just scale up the top here. So we have a bit of a angle. I don't know, there's a specific term for that, but I'm forgetting it. We have a bit of an angle to the base, a taper, I'm pretty sure. And then we can inset using I and extrude down using E to get kind of the base of our pot. Okay. I can add one more edge loop using R, Control R, and hit G twice to slide that loop up, and GZ to bring it down. I'll click on the object and shade it smooth and adjust the angle a little bit. So we're kind of happy with what we got. So here we have a solid opaque object, fine and dandy. Let's add our actual plants. Going to add a plane and just shrink it down. And we'll model this loosely into the shape of a plant. So I'm going to add a few edge loops along the side to turn this into like a big leaf. And then I'll move these edges in with G and X. To create kind of that leaf-like shape. Then we can take just the middle ones and kind of move them up. And the middle two even more, move them up. And this gives us something kind of leaf-like. I can take this new leaf that we've made and duplicate it around a few times. I might bring all of this down on both sides to give us a better angle for it. And then we'll kind of duplicate it around here. And then in the middle, we can add some larger leaf. Didn't really have a plan going into this one, so I'm kind of just throwing stuff together. We'll just make something plant-like that we can use. I'm far from a botanist, so I should be using reference because I don't really know what plants look like in general. But I'm pretty sure snake grass or something looks kind of like this, but I know it wouldn't have these leaves, but it's fine. Corn on the cob. I mean, yeah, it's definitely not my best work, but it will demonstrate my points thoroughly. So let's take this now and export this object as an FBX so that we can start texturing it in Substance Painter. So you can export it directly into our engine or somewhere else to texture and then re-export in the engine later. I'm just going to export it right into the engine as plant. Don't worry, we'll be out of here by 7:30. I promise you will not miss a single inning as long as you don't live too far away. So I'm going to make a new project for our new asset. I'm going to stick to PBR metallic roughness, alpha blend, or alpha test, or use the Unity settings. PBR alpha blend, OpenGL for Unity, and then we'll select our file. There we go. Our plant is here in Substance Painter. So I want all of these leaves to be together on a shared texture. And I want the pot to be together on a different shared texture. So I'm going to click on all of these leaves, or rather just one because we'll duplicate it, and give these a plant material. And we'll click on the pot and give it a pot material. And then re-export this for and then we'll just lay these out on the UV map together as well. Okay. And we'll pack our UVs. So now we have our UV'd objects ready to go. Ooh. Plants, plants, pot. So now we have our two leaves together on a material, and we have our pot on a separate material. So this is where things are going to get ugly. I am definitely not a great 2D artist, and I am definitely not the person to be painting plants because I hardly know what they look like. But let's go ahead and use Substance Painter to paint some plants here. So I'll make a base layer for my plants. And under my usual settings, I'm going to come in here and I'm going to make sure to check off opacity. And I'm actually going to paint in opacity. So I can paint in, say that I want my plant here to be something like this. Painting a plant. If you're good at painting plants, yours will turn out amazing. Actually, in industry, they don't always use photo scans of plants. Sometimes they do just straight up have the 2D artist paint plants, especially if it's a plant that's, otherwise would be quite hard to photo scan, like a fake one. I am painting opacity masks. So in Substance Painter, we have access to all these channels, but we're just working with opacity right now. We can start to paint in channels for our leaves. So filling everything with black by default so that it's transparent. And then the area that we want to be not transparent, we can fill with white. I'm sure there are better brushes and stuff for this too. This is fine for demonstration. Now we go back to our material. You can see we're just showing up where we painted the white. And this will export properly to Unity. So on top of my base now, I can add a new layer. And as long as I don't affect my opacity anymore, I can't paint outside of my mask. So this is just like an alpha mask in Procreate or something, right? I can now paint however poorly I would like, and it will not exceed these lines. Let's add some color variation because we are professionals. Great. We can switch over to our pot now, and we will texture our pot. So we'll find some kind of material that generally resembles concrete, and we'll go from there. Cool. Now we can export all of this together. And because we had two different materials set up, it'll export materials that we can use for our leaves and alpha clipping, and we can actually reuse these leaves wherever we would like. So before I export this, I'm going to just Alt-D, duplicate this leaf. And it'll share the same UV space because it's duplicated. So I don't really need to do too much. And it'll share the material as well. So let's export these textures. Repos, here, textures. And we're picking that same template, URP metallic. Export, save. Let's go back to our terminal scene where everything else is. There we go. And we can add our plant.
One another.
Yeah, that's we've been
Have you done it once? And so might be one of them. So everything belongs to points, so from appearance, we should.
So our plant, these are single-sided
Not from appearance, you could just do it.
because they're just simple planes. What is going on?
As long as you concentrate the box before.
There we go. So we want a material that renders both faces for specifically our leaves. That's why we have it on a separate material. So let's go into our materials and make some new ones.
Fine. 2 minutes.
We'll call this one leaves, and we'll call the other one pot.
I mean, for this, is a big change. So I'm making it.
Plant pot metallic map is going to be the plant pot metallic,
Really stupid, because I think just understand.
and the normal map is going to be the plant pot normal map. Fix that marking and make sure that our non-color map is also marked as non-color. We can just use the preset we made earlier. And we can drag that onto our pot, so that's nice and neat.
Some of them will make it not more obvious. This one.
And we'll make a different material for our leaves atlas. Oh, already did.
Happens a lot more obvious.
On this one, we're going to check off alpha clipping, except we're going to change the render face to both.
There's one, this one is not more obvious, this one now. It's the only one that's not there. So you can also make it.
And now, with the leaves material applied, we're rendering both sides of it.
So most of them see spots, just change the river type get them.
For the leaves material, we'll do the same thing. The plant's albedo transparency. The plant's metallic map.
The goal basically is these are what the layers are like actively when it's done. So
And the plant's normal map.
this is pretty good. And this one went over.
That's not it.
I mean, literally this was 4 syllables. So you can tell that they, yeah, but the moment one dies, they
Okay.
have to leave.
And that's everything put together. We've matched what we have here in Substance. We've painted our own alpha mask that we can now use to create these leaves, as well as a separate material for the non-alpha clipping front thing. So this is when we need to make new materials. This has been a bit of a roundabout demo as I just randomly make this plant in front of you, but hopefully that kind of helped you figure out where you might want to use these materials, since in this demo you had to make one for each different type of thing. Are there any questions? Has everybody put something in an engine during the class? Just out of curiosity, has everybody kind of done that? Because that'd be great. Awesome. So you can use those for your submissions. If you've got it all done, just make sure you submit it for the weekly the way that it's sort of lined out in the document. I'll show you one more use for that alpha stuff, which is we can use fill layers in our alpha channels to do some crazy stuff. So I could use something like this fence as alpha on my pot. And now I'm getting all that detail without having to model any of it. If you just build it all in Substance. Okay, that's pretty much everything I have for you. 720, we can call it there. Next week will be a lot longer and a lot more involved. This was like a precursor to like get familiar with Unity. Next week is like I'm going to throw everything at you that we've done all term at once, basically, in the form of you are going to build kits for environments. So that means we need to Find an environment, break it down, model each individual piece, which is something you should be familiar with. UV each individual piece. Create textures for those individual or shared pieces, and then build materials and apply them in Engine. So everything we've done to this point, we are going to do basically for 3 days or 3 weeks straight. Coming up, be ready. Take this much shorter, much less involved class as a slight break coming back from reading week to prepare yourself for what is going to be the rest of the semester. Okay? So have a good one, everybody. Go Jays. If you have any questions, I'll still be here till 8, of course, but I'll stop the recording.